Hi, in this video we are going to talk about collections.sort. Collections.sort is used to sort collections, especially list collections. Collections.sort has this syntax where it says it accepts only list collections. Now what are list collections? List collections are the collections that implement list interface. And the popular collections that implement list interface are array list and linked list. So we can use collections.sort to sort an array list and sort a linked list. Here is an example code. We have created an array list here, right? And we have assigned it to a list variable of list type. Then we have added 3 items to it. And then we are sorting it using collections.sort. Please note that to use collections.sort, we must import java.util.collections. So here I have imported java.util.star to avoid writing multiple import statements, because to make this program compile, I need to import java.util.list, java.util.arraylist, and then java.util.collections. So I've written java.util.star. So we added 3 items, we sorted it, and after sorting we are printing it. So what are we going to get? We are going to get 5, 10, 20, which is natural order of these integers. Then we are sorting this list in reverse order. So what are we going to get? We are going to get the reverse order. We are going to get 20, 10, 5. Right? That's what is printed here. Now an important note, wrapper classes, they implement comparable interface. So wrapper classes like integer, character, they have implemented comparable interface. What it means is they have a compare to function inside them, which can be used to compare two integers to decide which one should go first. And collections.reverse order, it uses this compare to function and returns a comparator which does the reverse of what is written in the compare to of these classes. That's why it sorts in the reverse order. Here is an example of collections.sort for sorting a list of items of user defined type. So I've created a user defined type point here, and this class has 2 members x and y. This class has a constructor, and this class implements comparable interface. So when a class implements comparable interface, you can use binary search on the objects of this class. You can use sort on the objects of this class. You don't need to do any extra work if you want to sort this array according to the same order as the compare to function implements. So here we are sorting the array of points according to x coordinate, and it's already implementing the comparable interface for this. So we can simply call collections.sort for this list. When you call collections.sort for this list, collections.sort uses this compare to function to sort the items. And what are we going to get the output? We are going to get 210, 510 and 1030, because 2 has the smallest x coordinate value, then 5, then 10. So that's why we are getting this output when we are printing the points after sorting. So we have sorted the list first, and then we are printing the list here in this part of the loop. So this is the for loop. Then we have end of main program and end of our main this class GFG. So this is an example of sorting a list of collections where your collection is of data type that implements comparable interface. Let us now talk about another example program where we use comparator interface to sort a collection. So we have the same point class. This time the point class does not implement comparable interface. So objects of this class are not comparable. And if we want to sort objects of this class according to x coordinate, then we need to do something extra. So extra that we have done here is we have written a separate class that implements comparator interface. So this is our separate class. I've called it myCMP. You can call it anything. You can call it point comparator. That would be a better name. So this class is used to sort the array of point objects according to our own criteria. And the criteria that we have used here is we are subtracting p2.x from p1.x. So the point is very clear. We want to sort the points according to x coordinate, increasing order of x coordinate, natural order, right? So what we do now to sort this collection or this list of points, we pass the list and we pass an object of myCMP. Now if you sort this way, and after that if you print the objects, if you print the points, you are going to get the points in sorted order according to x coordinates. So your output is going to be 220, right? The smallest x coordinate, then 5, 10, then 10, 30. In all the examples that we have discussed, we have used array list. And in all the codes, if I simply replace array list with linked list, all these codes will still work the same way. That's the beauty of collections. That's the beauty of using interfaces and generics. So collections.sort is based on generics. It's for non-primitive types and it's a part of collections. So if you see the Java documentation of arrays.sort and if you see the Java documentation of collections.sort, you will notice that there are multiple declarations of arrays.sort for different data types. So there are two versions in arrays.sort, one that sorts the whole array and one that sorts a subarray. So these two versions are declared for all primitive types, right? And then there are versions for non-primitive types. But in collections.sort, there are mainly two declarations, one that does not take a comparator and one that takes a comparator. One thing is, in collections.sort, we cannot use sort function to sort a sub collection like we can do for sorting a subarray. That function is not there. So we have only two functions in collections.sort, and these two functions serve the purpose for all data types, for all collections that implement list interface.